to calculate the force, the moment based on the given distance, moment arc, and the force. We also know how to deal with the moment rotated around a specific axis. We also know how to deal with the forces that created couples. Now, we are going to talk about force couple system. Force couple system is that a lot of time you are design a component. For this component, you're going to have multiple forces. Let's say we have 10, 20 forces, and maybe 1 or 2 points we have motor applied torque to it. So in this case, it will be a little bit tedious or too complex for us to visualize what's going on for the 20 forces applied to the same component. We would like to know how much force in x direction, y direction, and the moment at a specific location. If that's going to be the case, we're going to replace all the forces and moments with only 3 numbers. If it's a two-dimensional representation, it's going to be fx, fy, and the moment around the point you chose. So, what I'm actually talking about, I will start to read an example, correct? Okay, so I have a component like this. Obviously, we have 3 forces applied to it, which are 3 kN, 4 kN, and 5 kN, located all at different locations. And we try to find the force couple system located at A, which means if I see something like this, I just want to replace all the representations from all the components to be at point A over here. So in this case, we do need to have a free body diagram to represent everything I'm going to explain to you. But before we start, I would like to identify what are given and what we need to find. So we are given 3 forces and locations. I would like to know force couple system at where? A. So let's start. Over here, you might think, okay, all the forces has been applied to this one, so why do I need to have a free body diagram for this? If you redraw your free body diagram, what do you have? You have 4 kN over here. You have 3 kN over here. You have 5 kN over here. When I say it's a force couple system at A, what I'm expecting is going to be something like this. I have Fy, I have Fx, I have a moment at A. That is something I need. So You might have multiple forces over here, but over here you only have Fx, Fy, and the moment created by the forces of those three, created by those three forces. Is that clear? Everybody understand what I'm trying to do? Okay. So the resultant, let's start from the resultant. Rx. How many forces we have horizontally? Only two. AR, and I will need to specify the directions of the forces. So I'm going to use regular coordinate. Right hand side is my positive, upward is my positive. So with that said, the horizontal forces is going to be 3 kN plus 5 kN. That is my 8 kN. For Ry, I only have one force, which is negative 4 kN. That's all. So when you draw something over here, you will need to say, okay, this is going to be 8 kN. You actually have a force downwards. That is 4 kN. Question. Do I have any information of position used in those two forces? Okay, I don't. So it means that I'm telling you I am interested in at the position of A. If I move this position, saying I'm no longer interested in the total force at A, I want to move to this point. Am I going to change my resultant? The number of resultant if I move to this position that's going to be. Or the total force is if you represent everything over here, it's going to change your force. No, the total force at B is still 8 kN and negative 4 kN in X direction and Y direction. Okay, but the moment is going to be different. Before we move on, sometimes you do need to know the total force or the magnitude of the force. That is straightforward. It's just A squared plus negative 4 squared. You take the square root of it. So if you do that, this is actually 8.94. If you need to know the direction, the total force is going to be something like this, and obviously the horizontal force is going to be my 8 kN, and the horizontal is going to be my 4 kN. So the theta is going to be arctangent y over x. So it's going to be negative 26.63 towards to that direction. Sometimes you might need to have this kind of information to find out the resultant force. But giving me in this quest, if you give me Rx and Ry, that will be good enough. Okay, so those are the information of forces. How about the moment? The moment is going to be created by those three forces. So if I start from the 3 kN one, what is the moment R between the 3 kN and point A? Are they 500 millimeter or that's 1 meter? Here, 1 meter. Is that clockwise or is counterclockwise? Clockwise, so it's going to be negative. Right. Then for 5 kN. In this case, the moment arm is clear. It's 500 millimeter. So it's going to be 0.5 meter. Again, clockwise or counterclockwise? Clockwise. How about the 4 kilonewton one? What is the moment of? Are you going to calculate this thing, or is actually 404? 450? Perpendicular to it, so you don't calculate for the total distance, you just know what is perpendicular to this thing. So it's going to be a 0.45. Positive or negative? Negative. So it's going to be negative 7.3 kilonewton meter, and this is your answer for the moment at this position. Of course, you probably want to do this. Okay? Is that straightforward? Everybody understand what I'm talking about?
When you calculate the theta, where is that angle? Well, what's that 360 degrees represent?
This is complex. I'll redraw it over here. Okay. They are equivalent.
Okay.
Okay, so this is because I have negative force over here, positive force over here, so it actually something like this, or hey, let's say that. Make sense to everybody? Okay. So now, since you all agree the moment we can get the value like this, the question I have for you is, okay, is this moment going to change its value if I use different reference point or moment center? Are they going to be, in other words, are they going to be the same if I move the moment center to point B? Are they going to be the same? No, the moment does related to the position or moment arc. So this moment over here, that's also one of the reasons. When you see me writing down the moment, I don't just use M. Normally I will use M at its position. In this case, I'm using M at A. Okay, that's the reason why I always say, why I'm not using just M, I use M at 1. Okay, so be sure, it's just a habit, because in this case, I know which point I'm actually referred to. Okay, so now, since we all agree, the moment is going to be different if I move this reference point to somewhere else. If I'm telling you, can you find a location along this line where I don't have any moment? Can you do that? The moment, or in other words, the moment equals to 0. Can you do that? We can. How do we do that? So now, the moment over here is something like this, right? What my goal is, I'm moving this force upwards, maybe somewhere over here. Then the moment equals to 0. Because obviously, if you move this one upwards, the distance of 1 meter, 0.5 meter, is going to change its number. If you pass 0.5 meter, this part becomes what? Positive. So if we know everything like that, this is increasing those two, this remains the same, and this one is going to be decreased. So if you try to move this one around, you can find a position where this number becomes 0. Does that make sense to everybody? So that is somewhere we try to figure out. The easiest way of doing that is look at this configuration over here. We know, now I'm giving you, I want to move along this line. I have two forces by calculation, putting the resultant over here. I know the horizontal force is going to be 8 kilonewton, and the vertical force is going to be 4 kilonewton. Tell me which force, if I'm moving along this line, which force is going to create moment and which one is not going to create any moment?
X direction.
X direction is going to create moment. Y is not going to create any moment because this force is actually parallel to the moment of, which means the moment created by this force equals to 0, always. Okay? So, since we know the only moment is going to be created by 8 kilonewton, you can simply divide this number with 8. Then, if you do that, it implies if I move my distance, my reference point from 8 to this point, which is 0.913 meters away from the bottom, at this specific point, you don't have any moment. You can prove yourself by redoing the calculation over here. You should be able to find this number equals to 0. Okay? So it means that the moment can be different. Sometimes you want to try to find a place where there's no moment created on that specific position, which means when you try to measure anything over here, it's actually 0 moment or 0 torque at this position. But when you try to measure everything at point A, it suffers from the moment created by other forces with this value. It's also an index to tell you how strong your component needs to be designed. Obviously, the bottom over here needs to suffer from more torque or moment created by other forces. And at this point, you only need to worry about the force. You don't need to worry about whether the moment is going to break the material at this specific point. Does that make sense? Okay. There is one other thing I need to ask you. So that's fine. I know there's going to be a 0.913 meter along this line. Now you can do the same calculation. Say I want to move horizontally. So everything equals to 0, right? It's going to be the same. Nothing fancy. You just divide this one by 4. You're going to get this going to be 1.826 meters if you move to this direction somewhere here. Can you say I just moved my application point over here? So at this point, there is no torque applied to my component. Can you say that? Why not? You just shift everything from this point to here. What's wrong?
There's nothing there.
There's nothing there, right? Very good. So when we are doing this kind of calculation, it must be reasonable, physically accessible, which means all the forces must be applied to the same component. If you say, okay, I can apply, I want to move my reference point somewhere else. However, this point is within my component. What's the point? You're applying something to something. You're applying your force to something else. That doesn't make any sense. So when you are dealing with those kind of things, be careful. All the forces still need to be onto the same component. If you fail to do that, then the number, even though this is a perfect number, is an ideal number, you want everything to be just like wave this up. It's not going to happen because you are not applying any force on the components. Your calculation is no longer valid. Okay? I think it's enough. Still have 8 more minutes. Any question? That's pretty much about chapter 4. Do you have any question? I think homework 2 covered part of this. So can you guys do a little bit study over the weekend? If you have questions, let me know on Tuesday, because we're going to have exam on Wednesday. It's kind of intensive. If you don't practice this a lot over the weekend, then it's going to be tough for you guys to suffer.
Would there ever be a time whenever